So if there are issues in the data, that is how the data is. We cannot go back to the data team. Maybe assume that we have already gone to the data team. They came back to us saying, this is what we have. That's it. You go ahead. We don't have anything else. Like we have exhausted all our options. This is the final form of the data. And what is the next step? Look at this. We are going to follow something called imputation, which has been already intuitively guessed by most of you. If the data is like this, there is a variable which takes these values, which is present at most of the cases. Okay. But there is one missing value here. Maybe this is missing value, or this is an outlier value, or this is a default value, some issue. Let's put all of them under one cover only. There is a data that has issues here. I don't want to delete that row. No, I don't want to delete that row, because for me, x2 variable is present, x3 is present, everything is perfectly fine. It is available. That is important data for me. I don't want to, just for the case of one variable, why do I want to delete the whole row? I have this info present, all the other columns are present. Then I have to somehow fill something, and it should be acceptable logically. It should not create any bias, or it should not be any erroneous value. There should not be any human bias in it. I have to fill it. So can somebody tell me what is that you want to fill it so that it will hurt your overall analysis? Very minimal, but overall it is not going to really harm the analysis, and the data will also be intact and consistent. Tell me, what will you use here? What will you use? Either mean or median, isn't it?
Yes, sir.
Yes or no? Either mean or median. Those who have guessed by either mean or median, what is your logic? You thought that if something is missing, since it is also part of this data set only, okay, maybe if something is missing, if you keep the mean value or the median value, or to be on the absolute safe side, let it be median. If you keep the median value, then you will say that you're not creating any human or judgmental error. There is no judgmental error or human error. Shall I put 0 here? Shall I put 0 here? I think putting 0 is wrong. Rather than keeping mean or median is better here, isn't it? Replacing that with median is better. Why? You will hardly create any error. You can fill the value and you can go ahead. This is known as imputation. Remember, you need to be careful with imputation. This imputation is known as standalone imputation. What do you mean by standalone imputation? Sarada, we have not discussed mode at all. Okay. Nobody knows what is mode. Simply ignore that. Okay. It has no statistical significance. Okay. So what is this standalone imputation? What is standalone imputation? You take this single variable. You take this single variable and find the mean or median of all the values, and then fill this value that is missing. Standalone imputation. Now this you need to be careful. When will you do this? You know, there is a rule for it. There's a rule. Let me give you a counter example. Let us suppose there is one variable x2. It has some values that are given. It is available around at 40% of the places. 60% of the places it is missing. Let's say this is monthly income. Suppose monthly income. Monthly income is present at 40% of the places. At 60% of the places it is missing. If I have 40% of the data present, 60% of the data present missing, can I find the mean or median and fill this data with the mean or median? Can I fill the rest of the data with mean or median? What do you think? I don't think we are comfortable by looking at the 40% of the data, which may not be representative of the population, filling the rest of the 60% of the data, which was missing, with simply 40% of the data average. I don't think we are doing the right thing there, isn't it? I think we are creating human judgmental error. This 40% itself may not be complete representation of the population. Looking at the 40% data, filling the 60% of the data is wrong. So you need to be careful. Standalone imputation, when you do this standalone imputation, more than 90% of the data, more than 90% of the data is present and clean. Only less than or equal to 10% of the data has issues. Then only you do standalone imputation. You have to be careful here. Standalone. If most of the data is there, if a lot of the data is there, very small portion of the data is missing, then you do this. If the case is like this, you follow a different technique that we are going to discuss here. So we are not going to use the same technique for every variable. Depending on the type of the variable, depending on the percentage of missing, we have to follow a different technique. So we are going to divide this imputation into two parts. Let's say this is a variable. First we will see what is the type of variable. Is it discrete or categorical? Okay, or whether it is continuous. If it is discrete or categorical, if it is continuous, we will follow different steps. Even if it is continuous, is it 10% issues, or is it 10 to 50% issues? Then there is another method that we follow, or the more than 50% issues. That means a lot of the data has issue, or very small portion, less than 10% has issues. Then we follow a different technique. Here we follow a different technique. Here we follow a different technique. Even in discrete also, for 10%, less than 10% issues, there is a different technique that we follow. 10 to 50% issues means there is some erroneous data which amounts to 10 to 50%. More than 50% of the data has issues, then we follow a different technique. Okay, let us see what are these techniques. First we will start with the simple one that everybody can see. That what is it? The first one is missing value treatment for the first variable, which happens to be utilization. By the way, what was the issue with utilization? What was the issue with utilization? Can you tell me how much percent of the issues were there in utilization? First of all, utilization is a continuous variable. Continuous variable, it takes values between 0 comma 1. Continuous variable which takes values between 0 comma 1. What was the issue? Can you go back to the code and tell me what is the issue with utilization? It has outliers. How much of the data was clean? How much of the data has issues? How much was clean? How many data points have issues? Clean percentage is 97%. Issues are around 3%. Do you think you find the median of 97% of the data, replace that 3% issues? Do you think that is justified? 97% of the data is present and it is clean. 3% of the data has issues. Do you think it is justified? By looking at the 97% of the data, I can confidently replace the 3% of the data with the median value, right? Yeah, perfectly justified. So if the variable has missing values or outliers less than 10%, if it is continuous variable, then a simplest method, what is the simplest method? Replace with mean or median. If you ask me, my suggestion, usually go with median. Okay, go ahead with median, which is a true representation of the center. That is a Euclid. Here there is not much of thinking required, because a lot of data is present, very small portion of the data has issues. There you don't need to think a lot. Okay, so here we will go back to the code file. We will revisit our utilization data cleaning scenario 1. Utilization has 3% issues. Check this out. Utilization has, strictly speaking, it has 2.5% issues, or roughly 3% issues. 97% data clean. Find the median utilization. Find the median utilization. Look at the cleaning process here. You have to understand this cleaning process carefully. Okay. What am I doing? I'm trying to replace the values where it is more than one, wherever utilization is more than one. I want to replace it with median, which is 0.154. Okay. So here, instead of disturbing the original variable, I'm creating a new variable called util new. Okay. As of now, util new will be nothing but same as utilization. Now, wherever utilization is greater than 1, I'm trying to get that counter. So first, let me get this one. Let me show you the output of this one. What does this mean? Can somebody tell me what is this util temp boolean vector will do? What does it do? It has true, false, and all that. Most of them are false, but there are some truths. What does this do? Tell me. What
Checks
does it?
value if it is greater than 1.
It checks whether revolving utilization is greater than 1 or not. Okay. If I simply look at the count, I will get 3% of the places where it is greater than 1 actually. So it will even give me the count of true false. Only at 3000 records it is greater than 1, which is happening to be around 2.5% or so. Remaining 1,46,000 cases, it is perfectly less than 1. Now here is the place where I am writing the code for creating a new variable. Instead of cleaning the original variable, the usual standard that is followed is keep the original variable as it is, create a new variable that is a cleaned version of this variable. Later on, before building the model in the final data set, drop the unnecessary variables. Here, util new is the cleaned version that I'm going to create, which is simple copy right now. Now I understand what this part of the code is doing. Can somebody explain me what this part of the code I'm trying to do? Right now in utilization new, both erroneous data, right data, both of them are there. What is this second line going to do? Tell me.
In util new, which is greater than 1, it is replacing by median.
Exactly. So what this part of the code will does is, so you will go to the data set within that specifically util new. If you apply util new temp bool vect, that means wherever utilization is greater than 1, it will be true. That means those 3000 records will be fetched here. Only those 3000 records will be fetched. They will be replaced with median. What about the rest of the records then? The rest of the records will have the same value as the revolving utilization of unsecured loans and lines. Rest of the values will be same as data. Only wherever it is more than 1. In fact, I don't need to create this separately. I can directly take this condition and put it here. But to keep it simple, I kept it like that. So this way, if you do it, it will automatically update this with median utilization. Pandas is throwing us a warning saying you are slicing and dicing and all that, which we are intentionally doing it. We are actually updating only few rows. So if you check this out right now, you will get to know the maximum value of util new, the cleaned version is 1. Minimum value is, what is the minimum value? Minimum value is 0, maximum value is 1. So here we found wherever utilization is more than 1, we replace them with median. If there's a for loop that you can write, if there's any other way, you can follow that as well. There are multiple ways of doing the same exercise. If you look at the percentiles, you will see that util new, which is a cleaned version, has the maximum value as 1. Quickly execute this. While executing this, if you have any questions, please do let me know. Okay, go ahead, all of you. Quickly execute this part of the code.